Welcome. Institute of Aeronautical Engineering IARE. Now we shall move into the topic in the next slide. This is the math subject. The graphical representation of Rolle's theorem presented by B. Harshavardhan Yadav 22951A 6737. Mean value theorems. In mean value theorems, there is the first thing, that is Rolle's theorem. Let f of x be a function such that there are 3 points for the Rolle's theorem for the f of x function. That should be done. His comes in closed interval a comma b. First thing is that f of x should be come in the closed interval a comma b. It is differentiable in open interval a comma b, and f of a is equal to f of b. Then there exists at least one point E in tab such that f dash c is equal to 0. Then f dash c is sets that differentiation of c is equal to the 0. That should be satisfied. The geometrical representation of Rolle's theorem. Let a comma b be a function satisfying the three conditions of Rolle's theorem. Now graph. We should take x-axis and y-axis, and middle is 0 point. Then there is a to b continuous function at x is equal to c. It is the highest. Now for the next graph, they took x and y axis, and from the origin O they took a to b. From down it is x is equal to c. The point is touched at x is equal to c in the both the graphs. Now shall we discuss about the graph in the from the points. Y is equal to f of x is a continuous curve in the graph. Continuous curve in the graph. There exists a unique tangent line at every point x is equal to c, where a is greater than c, a is less than c, c is less than b. The ordinates f of a, comma f of b at the endpoints a b are equal so that the points a and b are equidistant from the x-axis. By Rolle's theorem, there is at least one point x is equal to c between a and b on the curve. Now we should verify the Rolle's theorem for the function f of x is equal to sin x e power e square, or e minus e into e square e power x sin x plus in 0 to pi. Solution. Since sin x and are both continuous functions in 0 to a interval, therefore sin x by e is also continuous in 0 interval. Since sin x plus e be derivable in 0, then is also derivable in 0, x. 0 sin x e power x e power 0 and f of x sin e power x is equal to 0. Thus, all three conditions of Rolle's theorem are satisfied. There exist of such that f of c minus 0 how faces sin cos minus sin x. Since sin x and are above continuous functions are 0 to a, therefore sin x by e is continuous in 0. Sin x and e be derivable in 0, then is also derivable in 0 comma x 0 sin e minus 0 and f of x sin e power x. Thus all three conditions of Rolle's theorem are satisfied. There exist such that f of c minus 0 now faces sin cos f of c 0 is equal to greater than cosine minus sin 0. Hence Rolle's theorem is verified. Verify Rolle's theorem for the functions log square plus ab by a x into a plus b in ab a comma b. Solution: let f of x og log x ah plus log x minus log a minus log b. First one point. Since a is a composite function of continuous function in a comma b, it is continuous in a comma b. F of x exists for all log. Thus f of x satisfies all three conditions of Rolle's theorem. 3. A comma b f of c equal to 0. Hence Rolle's theorem verified. Verify whether Rolle's theorem can be applied to the following functions in the f of x is equal to tan x in 0, 1 and f of x minus 1 by x in minus 1, 1. First one, fix f of x is discontinuous at x minus a as it is not defined there. Thus, Rolle's theorem is not satisfied. Hence, we cannot apply the Rolle's theorem here. Rolle's theorem cannot be applicable to f of x is equal to tan x in 0, 0 to x. F of x is equal to 1 by x in 1 minus 1, 1 to 1.11 is discontinuous at x. Hence, Rolle's theorem cannot be applied. Verify Rolle's theorem for the function f of x minus 1 minus a x minus b where m a are positive integers in ub. Solution: since every polynomial is continuous for all values, f of x is also continuous in a to b closed interval x minus minus b m minus n into x minus which exists that f of x is derivable in a comma b, a and b. Thus three conditions of Rolle's theorem are satisfied. There exist of a such way that f of c Rolle's theorem is verified. Using Rolle's theorem, show that g of x is equal to 8x minus 6x minus 2x plus 1 has a 0 between 0 and 1. G of x is equal to 8x minus 6x minus 2x plus 1. Being a polynomial, it is continuous on 0 to 1 and differentiable on 1, 0. Now 0 and 1, g of 1 minus 86 minus 2 minus 1 minus 1. Also g of 0 minus g of 1. Hence all conditions of Rolle's theorem are satisfied on 0, 1. Therefore, there exists a number cc 0, 1 such that g dash c minus 0 d dash c of x is equal to 24x square minus 12x x minus 2 d g d dash c g dash c minus 0, minus 24, only values 0.63 lies in 0.1. Thus, there exists at least one root between 0 and 1.